So we will see about arrays versus linked list. So you would have understood after learning the arrays and linked list separately that the first difference we can notice is we have the prior knowledge of the number of elements in the list. For example, in array, if you see, you know already the number of elements available, and so this help us to allocate the required amount of memory in advance. So if you want to have the you have already the fixed number of elements in your hand, and you have to choose which data structure to use, whether to use array or whether to use linked list. Your natural choice will be array, because array works with the static knowledge of the number of elements beforehand itself. So a natural choice would be array. In the linked list, what happens? It is okay if you have the number of elements in the list or not, but the problem comes is that it takes more space when you have to have too many pointers. As you have seen, like in arrays, we don't have many pointers, just the index. Based on the index value, you will go to the exact location. But as you have seen in linked list, the next field is pointing, or in double linked list, you have previous field, next field pointing. So there are so many pointers involved, which will take lot of space. Even though the space is scattered in linked list, it will take lot of space due to the pointers. Next, we do not have prior knowledge of the number of elements in the list. In this scenario, you cannot go with array, because you won't know if you need more memory, or you won't know if you want you cannot have a dynamic memory allocation in case of array. So when you have a scenario where you don't know the number of elements beforehand, you will go with linked list. Why? Because array will go out of memory. Suppose if it wants more memory, you cannot redeclare in array, but linked list does the dynamic allocations by just pointing out, pointing out, pointing out. So and you cannot make redeclaration in array, but there is an option where you can copy the contents of the elements present in the array into a new array, and then append it to with the elements which you want to be inserted, if in case you want new elements to be inserted. For example, I have created an array of size 10 where I can insert 10 elements. Now what happened? Actually, I want to insert 11 elements. So in that case, what we have to do? We have to copy all the 10 elements in another array. We have to create another array of size 11. And then you have to copy all the elements which is present in the previous array into the new array. And then you have to insert the 11th element. But in case of linked list, it is not that. So the memory is also not wasted in case of linked list. So you have two scenarios where you have the number of elements in the list already you know, or you don't know the number of elements in the list. But in two scenarios, you have different reasons to identify. First one is like the allocation of memory is in advance. So this is very natural for the array. And linked list is also a natural choice, but the point is it takes too many space for the pointers. In the second scenario, the array takes lots of space because you have to copy the elements from the old array into the new array and insert the new element. But in case of linked list, you can dynamically allocate elements as it comes, except it takes space for the pointers. Now, another scenario, like we need sequential access to the elements in the list. It has to be step by step. So tell me, Sanvi, so in this case scenario, which will you choose, whether array or linked list? We need sequential access to the elements.
Array.
Yes, array. Why array?
Because first, to access those elements, you just have to keep the index number.
Can you be a bit louder?
To access the elements in the array, we have to know the index number.
Yes. So it is sequential. As you know, array will be stored in contiguous memory location. So what happens here? It has a fast access of data, as you said, because of the index. But if you take the nodes of the linked list, in a linked list, we have several nodes which are scattered in different portions of the memory. So what happens here? The process gets slowed down to access the data. As you saw, to insert in the middle of the linked list, we have to go to the head and then go to the next. We can't directly go to the middle of the linked list directly. We have to address the head field and then go. So there, the sequential access means we have to go for array because it gives fast access because of its contiguous memory location. Whereas in linked list, it is slow access because of its scattered memory location. Here it is contiguous, here it is scattered. So there it becomes fast, here it becomes slow. Access becomes slow. Next, we need an indexed or random access to the elements in the list. So in this case, random access in data structures means it refers to the ability to access nth element of a list. Nth element means any element like 10th element or 11th element, any element. So with the knowledge of the starting address of the array, and the index will be accessed, and array can directly access the required location using the formula, which we have discussed using row column matrix. We had a formula. So based on that, it will go directly to the location. If it is 1D, not a problem, it's like I plus 1. And if it is 2D, we have row order matrix, column order matrix. You have a formula for it. Based on the formula, you will identify the location and go directly to the place where you want to access a particular element. So this is how is the time complexity here? It is a constant time complexity. So there is no hike here, right? It is very, there is no spike here. It is very constant. But if you see linked list, it moves from one node to another. So until the required node is found, you have to move one by one from the starting, and there is no formula for it. Just you have to know the head address, and then you have to go next, next, next. So this becomes very complicated, and we don't have indexing here. So when you need of something called indexing, you have to go for array. And then the number of elements to be stored is small in number. You have only a small number of elements to be stored. In this case, you can use array because only contiguous storage is available. So as I said, if I want to store 5 elements, you will have contiguous 5 locations available and you can store. And but if the elements increase, then it becomes difficult to find that continuous space. In that case, the option will be linked list. So when the element number is smaller, you can find the contiguous memory location easier. Like if I want to insert 2 elements, it is easier. Up to 10, it is easier. But like if I want to have 100 elements, in that case, finding 100 continuous memory location, it's difficult. Like 1 to 100, the memory space have to be free to store the 100 element array. It becomes difficult. In that case, we can go for linked list because it is scattered. And insertion and deletion are mostly at the end. For example, in this scenario where you want insertion and deletion at the end, array would be a good choice because it does shift operation. Whereas in linked list, you should have an extra pointer to store the uh, last node because it will be helpful. You have to store whatever element you're going to shift it or do something. In order to save the data, you have to have some temporary variable in which you will store the node, and then you will bring it back. So in that case, insertion and deletion mostly at the end, we can go with array because it does by shifting operation, which is very easy. But in linked list, you have to store the last node in some element, and then you have to insert the new node. Then you have to make the last node point to the new node as the next field, and then next field of the new node has to point to null. So these are the operations involved when you have to do insertion and deletion at the end for the linked list. So it is very a huge computation. So these are the scenarios. Based on the scenarios, we have to choose whether we have to go for array or whether you have to go for linked list. So next we'll go with stack. So as I've already told, stack is like a bag. So you will insert at the one end, and the same you will take the books at the same end. We don't have like two ends, we have only one end. So stacks are the linear data structure in which elements can be inserted and deleted according to a policy decision. So whichever element you're inserting at the last only can be taken first. For example, I'm dumping everything inside my bag and I'm keeping the last one as like my pouch or something. The last one which I've kept inside my bag only I can take it. Then only I can access the end element, like whatever it might be, some books or something. So whatever you're inserting at the last will be removed first. So that is the speciality of stack. So that is why it is called as last in first out, LIFO. So that's all about this stack and then array. So today we had this discussion on the insertion. We saw like a single linked list insertion at the beginning, in the middle, and at the end, all combined in a single program. I've taken it at the different sessions because to bring understanding, because it's a very big program, I wanted to bring it with the diagrams and the algorithm. Now we have to see about double linked list, but we will, as parallel, we will be seeing about the stack, queue, trees, but the programs also will be going in parallel. The point is you have to revise it daily. As I've already told, to revise the concepts whichever I've taken till now. Have you revised it, Sanvi?
Yes, ma'am.
Yes, because when you come to next class, you can't be blind. Like we can't have a blind understanding. Data structure is all about practicing. The more you practice, the more you can understand. Like how you ask question today, so it shows that you have revised, you have understood something out of this. So it, revise it daily. I am sending the PPT also. So revise whatever we are making discussions on the programs, write it on your own, study the program, write it on your own, try creating notes, and then make some arrangements for that, or change the variables initially. You can do that. You can change the variable names, and by changing the variable names, somewhere you would have missed to change the variable name, and when you run the program you will have some error. So that error will teach you how to correct the process of debugging. So when you do it by yourself, it gives you more understanding. I like typing the program line by line, but it will take more time because we have 1 hour. So I thought like I'll give a stretch program and then explain it. But if you want me to type program line by line, I'll do it. So how do you want, like explaining in the same way, or you wanted to me to type line by line? Sanvi, are you there?
Yes, ma'am.
Yeah, you want me to type it line by line in the next class, the programs, or are you fine with what I'm doing, like giving the
Ma'am, it's fine with what you're doing.
Yeah, okay, fine. So are you finding difficult with the programs?
No, ma'am.
Okay, fine. So are you, I told you to write like algorithms for array rotations, and I know you have school works, and doing parallel it's difficult, but just when you have feel like very tired or something like that, just take a note and make a rough, like step 1, step 2, step 3. You can take one program and start writing algorithm for it. It gives you practice, because when we go for algorithmic analysis, you may find it difficult actually when we make time complexity, space complexity analysis. So I think writing algorithms daily will give you a good understanding, because when you go to pseudo code, it's even more complicated. So that's why. Okay, practice daily some algorithm practice. Okay, fine.